Hello students, welcome to the another new lecture of the engineering chemistry course. Before starting the today's lecture, just have the recap of the previous class. In the previous class, we have completed the topic glass. In the last class, we have discussed about the various types of the glasses, in which we have discussed about the soda lime glass, potash lime glass, lead glass or flint glass, borosilicate glass, laminated or the safety glass, fiberglass or glass wool, photochromic glass and the reinforced glasses. By completing the various types of glasses, we have finished the topic glass, and the last topic of the unit 4 is the lubricant. So today we are going to start the topic lubricants. In the today's lecture, we will cover the following topics: introduction, definition, functions of lubricants, classification of lubricants. In the classification, we will discuss about the liquid lubricants in the detail in the today's lecture. So let us start. As we know that in industrial machinery, there is a mutual rubbing of the surfaces, which are the metallic surfaces, and these metallic surfaces move against each other, which causes the resistance to its motion. This resistance is actually called the frictional resistance. Now the question comes that why frictional resistance occurs. So the main reason behind the frictional resistance of the moving metallic surface is behind the metallic surface structures. All the metal surfaces possesses many irregularities. By seeing the electron microscopic images of the metallic surfaces, we can see that metallic surfaces are not very smooth. These metallic surfaces are actually having the roughness. So this is the scanning electron microscopic image of the mirror polished platinum surface. So we can clearly see in this picture that there are the many irregularities in the forms of peaks and valleys at the metal surfaces. So these irregularities are the main cause of the frictional resistance. So basically, when the metal surfaces are having the peaks and valleys like structure, then this will cause the frictional resistance. Why? Because when such two metal surfaces are moving each other, the contact area is only a small fraction of the apparent total contact area, because the contact is through the peaks. Suppose these are the metallic surfaces peaks area. Now if the metal surfaces moves over each other, then two possibilities may occur. First, both the surfaces contact only at the peak area. Now these may contact only at the peak area. So in such condition, high pressure is developed at these small contact areas, resulting lot of wear and tear of the machinery parts, and ultimately it restricts its motion. So this is the frictional resistance. So if the metal surfaces contact peak to peak contact, that means high pressure at the small area will generate, which will cause the wear and tear of the metal surfaces. Second condition may occur when the contact is between the peak to valley contact. That means this peak part may contact to this valley part. This type of contact may occur. So if peak to valley contact between two metal surfaces may takes place, then this will cause the interlocking of these peaks and valleys, which will cause the frictional resistance. So the fundamental fact is that the metal surfaces actually are not very smooth. All the metal surfaces possesses irregularities in the forms of the peaks and the valleys. This type. So metal surfaces are irregular metal surfaces. Now when two metallic surfaces moves over each other, two possibilities are there. First, when they contact peak to peak contact, or the peak to valley contact. In both the cases, the restriction will be there towards its motion. Why? Because when the metal surfaces contact peak to peak, that means high pressure developed within the smaller areas. So this will cause lot of wear and tear of the machinery parts. If contact of two moving surfaces takes place peak to valley contact, so this results in the interlocking of the peaks and valleys, which ultimately causes the frictional resistance. So this will cause a great problem to the industrial machinery. So now what is the solution? Solution is the lubricants. So basically the lubricants are the substances which are introduced between two moving or sliding parts of metal surfaces to reduce the frictional resistance between them. Now question comes, how they reduces the frictional resistance. So basically these lubricants covers all the irregularities on the metal surfaces. Now there is no possibility that metal surfaces comes into direct contact with each other. If there will be no direct contact between the metal surfaces, that means no peak to peak, no peak to valley contact, and hence frictional resistance minimized. So this is the lubricant which reduces the frictional resistance by avoiding the direct contact between metal surfaces. Now what is lubrication? The process of reducing frictional resistance between two moving or sliding surfaces by introduction of lubricants between them is called the lubrication. Now third terminology is the tribology, the study of the phenomenon and mechanism of friction and the lubrication of metal surfaces is called the tribology. So three main definitions are here. First is the lubricant, second one is the lubrication, and third one is the tribology. So lubricants are the substances which are introduced between two moving or sliding metal parts of metal surfaces to reduce the frictional resistance between them. And the process by which it reduces the frictional resistance is called the lubrication. And what is tribology? Tribology is the study of phenomenon and the mechanism of friction and lubrication of metal surfaces. Okay. So now coming towards the functions of lubricants. The main functions of the lubricants are: the lubricant acts as a thermal barrier and reduces the friction and wear and prevents the welded joints. It also acts as a coolant. It acts as a seal and prevents the entry of dust, moisture and dirt between the moving parts. Some lubricants act as a corrosion inhibitors, thus reduces the operational cost, because the layer of the lubricant onto the metal surface actually prevents the direct contact of the metal surface with its environment. So it prevents corrosion also. Now next is the classification of the lubricants. On the basis of the physical state, the lubricants are classified in three main categories. First is the lubricating oil, second semi-solid lubricants, and third one is the solid lubricant. So let us consider first, that is the liquid lubricants. Those are the lubricating oils. The lubricating oils are further classified in four categories, that are mineral oil, vegetable or animal oil, blended oil, and the synthetic oil. So let us discuss one by one each. First we will take the lubricants which are in liquid condition. Those lubricants are known as the lubricating oil. The main properties of the lubricating oils are It reduces the friction and the wear. It also acts as a cooling agent. It prevents the metal surface from corrosion. It also acts as a sealing agent. These liquid lubricant, that means lubricating oils, are further classified into 4 categories, that are the mineral oil, vegetable oil or animal oil, blended oil, and the synthetic oil. So let us discuss one by one. First is the mineral oil. Basically, the mineral oils are obtained from crude or petroleum, crude oil or the petroleum on frictional distillation. In the fuel chapter, we have already discussed that mineral oil are the part of the various fractions collected by the fractional distillation of the crude oil or the petroleum. So, the source of the mineral oil is the crude oil. The properties or the main features of the mineral oil are, these oils are the hydrocarbons having 15 to 50 carbon atoms. So basically the composition contains C15 to C50 carbon atom in the mineral oil. They are quite stable under the operating conditions. So this is the very important quality, that if the machinery parts work at very high temperature, then the mineral oil are stable at those operating conditions. These are cheap, that means not so much expensive, and are widely used. These are readily available in abundance, but the main drawback of the mineral oil is their poor oiliness. So all above 4 are the qualities, but poor oiliness is the drawback of the mineral oil. Next is the vegetable oil or the animal oil. Basically, the vegetable or animal oil are obtained from the natural products. The main features of the vegetable oils are, these are the most widely used lubricating oil before the advancements of the petroleum industry, that means before the mineral oils. These are expensive oils. Mainly fatty acids are used in the category of the vegetable oil for the lubrication. These oils are not so much used because of some disadvantages. The main disadvantages with the vegetable oil or animal oil are, first, these undergoes in oxidation and forms gummy or acidic products that are harmful for the metal surface. So these are readily react with the surrounding oxygen and forms the gummy or the acidic products, which may causes harm to the metal surface. Secondly, they can easily hydrolyze in presence of the moisture or the water. So because of their chemical reactivity, they can easily oxidize or they can easily hydrolyze. So both of these properties are harmful as a lubricant for the vegetable oil. To achieve the good lubrication from these oils, some special additives are added to them which incorporate desired properties. So those additives are sperm oil, lard oil, castor oil or the olive oil. So basically what we have learned till now, 2 types of lubricating oil. First is the mineral oil, second one is the vegetable or animal oil. Mineral oil are cheap and widely used, and these are the hydrocarbons containing C15 to C50 carbon atoms obtained from the crude oil. But the main drawback are the poor oiliness. These are quite stable, but their main drawback is the poor oiliness. While the vegetable or animal oil possesses very good oiliness, but their drawback is their reactivity. They can easily oxidize or they can easily hydrolyze and form the harmful products for the metal surface. So both these oils have some good qualities and some drawbacks for the lubrication. So now what to do? So coming towards the blended oil. Basically blended oil are the mixtures of the lubricating oil mineral oil or the vegetable oil with some specific additives. And additives are some specific substances which are added to the lubricating oil to improve their quality. So what are the blended oil here? Basically, the blended oils are the mixture of the raw lubricating oil plus additives. Now, what is the raw lubricating oil? Raw lubricating oil may be the mineral oil or it may be the vegetable or the animal oil. So basically, what we are doing here, we are mixing the mineral oil or vegetable oil with some additive. So the role of additive is to improve the quality of the lubricating oil. So now, what is the need of the blending? Why we add some additives to the basic lubricating oil? As we know that no single oil can serve as the best lubricating oil in all respects. Thus, for providing better lubrication, additives are added so that the blended oil fulfill desired properties to the lubricant required for particular machinery. So what are these additives? Various type of additives may use to form the blended oil. So let us have a look on these additives. First is the extreme pressure additives. Extreme pressure additives are basically the organic chlorine, phosphorus compounds or the sulfurized fats. So what is the function of these chemical compounds which are known as the extreme pressure additives? Basically, these chemical substances are chemically adsorbed on the metal surface and form surface layer that increases high pressure temperature bearing capacity. That means the role of extreme pressure additive is to increase the temperature and pressure bearing capacity of the lubricant. So these are helpful to form the stable lubricant layer onto the metal surface which can work at very high temperature as well as very high pressure. Second additives are the oiliness carriers. These additives are the vegetable oil or the fatty acids because these possesses very good oiliness. So the role or the function of the oiliness carrier are to increase the sticking nature and strength of the oil film. So these improves the sticking qualities of the oil. Third is the thickness additives. Basically, the polyesters and polystyrenes are used as thickness additives to the lubricant. These thickness additives are used to provide high viscosity to the lubricating oil. Next one is the corrosion preventers. For corrosion preventers, the organic compounds of phosphorus and antimony are used. The function of the corrosion preventers additives is to provide the protection against the corrosion. Next additives are the antioxidants. Basically, aromatic, phenolic or the amino compounds are used as an antioxidant. The role of these antioxidant additives is to retard the oxidation of the lubricating oil. Next additive is the viscosity index improver. Hexanol is used as the viscosity index improver additive. The role of this is to maintain the consistency in viscosity. That means if the working temperature of the machinery is varying temperature, that means sometimes it may goes up and sometimes the temperature goes down. So the role of hexanol is here that it maintain the consistency in viscosity at the varying temperature. So those were the blended oil and their additives. Now the fourth category of the lubricating oil is the synthetic oil. Basically, the synthetic oils are the lubricating oils which are synthesized in chemical plants and refineries by chemical reactions or the polymerization. For example, polyglycol ethers silicones and the fluorochlorohydrocarbons. So basically synthetic oils are the artificial oils or the man-made oils with the desired quality. These synthetic lubricating oils are used in most drastic and the severe operating condition because these are the man-made. So what qualities we want to prepare in the lubricating oil, so we include such type of chemicals which can provide those qualities. So these synthetic lubricating oils are very useful in drastic and the severe operating condition, that means extremely high pressure and the temperature conditions. For example, in the aircraft engines, under such conditions common lubricating oil does not work satisfactorily. The main properties of the synthetic lubricating oils: it works over a wide range of temperatures such as -50 to 260 degrees centigrade. These are very stable, non-inflammable, high viscosity index, high flash and fire point, and low freezing point. So these are some very good qualities of the synthetic lubricating oil which makes them useful for providing the lubrication in the drastic condition, that means high temperature and the pressure conditions. Basically these synthetic oils are the man-made oils. Various type of synthetic oils we can use, for example halogenated hydrocarbons, organophosphate esters, silicones, dibasic esters, etc. The main use or the main application of these synthetic oils are: these can be used in submarines, can be used in the aircraft. These are very moisture repellent, that means they are very stable, used for the lubrication in the gas turbines and the turbojets, etc. So these are all about the synthetic lubricating oils. Now let us revise what we have discussed in the today's lecture. In the today's lecture we have started with the topic lubricant, and we have covered the introduction part, definition, functions, classification of the lubricants, and then we have gone through the liquid lubricants. So that's all for the today's class. Now it's time for the learning check. Read the question on your screen. What is the difference between blended oils and the synthetic oil? Think about its answer and we will discuss its answer in detail in a tomorrow live class. Till then, take good care of yourself and keep enjoy e-learning at home. Thank you.